Hi everybody, it's a great privilege to be here in the home of mechanical engineering. I'm here to tell you about the global commercial opportunity that the Pulsar engine represents. Just to set the scene, the Pulsar engine technology was the winner of the 2014 Shell Springboard national competition. We were in competition with 110 other low-carbon technologies. To tell you a bit about Oaktec, this has been a long story. I won't bore you with all the detail, but to give you a potted history, the idea for the Pulsar engine is now 30 years old. In 1999, we received some funding to build a first-generation prototype, and that was effectively the beginning of Oaktec as a business. The prototype engine was very successful, it worked very well, but at the time we were sort of the two inventors in a shed, and we had no networks, no money. We didn't know what to do in terms of commercialisation of the technology. So we withdrew the patents and moved on to other things. Oaktec as a business is best known for development of hybrid systems. We were the first people in the world to use energy recovery in motorsport successfully. We were supported at the time by Bosch and Honda to develop a Honda rally car. We had a Kerr system winning motorsport events 5 years before it was introduced into Formula One. Our interest in hybrid systems actually took us back to the engine because we were looking to develop a range extender technology. And only 18 months ago, we received some funding to build a second generation of the prototype of Pulsar. And through having funding, we were able to bring in some industry expertise to help us develop the prototype. Now, I'm the eternal optimist, but when we got this second prototype on a proper test rig, even I was amazed by how well it performed. Sorry. Oh, thanks. There we go. So what is Pulsar? The internal combustion engine has been around for over 120 years. The piston engine is still the way that most engines operate. Pulsar is a four-stroke piston engine, but what we did was we looked at everything that makes a combustion engine efficient and sort of thought outside the box and came up with a novel concept. By doing that, I mean, the original engine was designed to be a racing engine, but we realised that an efficient engine is an efficient engine for whatever application. So we've taken a conventional architecture, done it in a different way, and we've got considerable advantages in all the key areas. So we have more power, we have lower emissions, and we have better fuel efficiency. But the key thing that makes this engine completely different is it is ideally suitable for burning gaseous fuels, and that's a real USP of the technology. To give you a simple analogy of how it works, if we decide to take up athletics and go running, we have fuel in our body, and we run and we breathe, and it's the breathing that dictates how fast we run and how far we get, or how far we can run. If you take an elite athlete like Mo here, Mo has the same amount of fuel in his body, but when he runs, he breathes more efficiently and with less effort. So he can run faster and further. To explain the global market opportunity, every roadmap for future fuels is looking at gas. Every nation and every region is looking at gas for fuel security and for low emissions. There's 45 million small anaerobic digestion plants in China alone. 500,000 CNG-powered taxis, tuk-tuk taxis, are sold in India each year. As part of my team, we now have funding from Innovate UK as part of the Energy Catalyst programme. That has enabled me to employ the former TVR design team to work with me on the engine project. I have two lawyers who are working with me on contracts and development of IP. And our plan to move forward is sorry, I have to finish. Okay, sorry, we have a UK filed patent, but we need to develop and secure the IP globally. We're looking for a CEO to take the business forward. The £10 million is an arbitrary figure, but we need a lot of money to make this into a global product. Thank you.